This session, we'll go a little deeper and try to understand uh, read anatomy, write anatomy, rack awareness, and what are the differences between Hadoop 1 and 2 and Hadoop 1 and MapReduce in 1, and what are the primary differences with Hadoop 2. Okay, so this is a little bit different. I mean, the approach I'm doing right now is I'm trying to lean more towards Hadoop 2 because industry is moving towards Hadoop 2 and most of the people are in fact implementing Hadoop 2. When I say Hadoop 2, right, important features or the new features that have been introduced, which I think, as I've been explaining with this diagram, well, as and when there is a chance to explain, I'll be comparing with Hadoop 1 and 2. All right. Now, quick questions. Can you please tell me what are the important components of Hadoop? What are the core components of Hadoop? Just that's right. Yeah, Balaji says HDFS. Right, HDFS is one.
MapReduce.
Perfect. MapReduce. Now, within this, there are what are the components? Within this, what are the naming convention I've introduced here? So, within this, what are the daemons within HDFS and what are the daemons within MapReduce?
In HDFS, it's called a master server, name node, or it has job tracker. And when it comes to its slave nodes.
Yep. Job tracker.
Job tracker.
And here, the slave nodes.
Data node and the task tracker.
Perfect. Got it. And here, the slave component is task tracker. Now, all this is Hadoop 1. Now, when I introduce Hadoop 2, what is this called? The Hadoop 2, your HDFS remains the same. Okay, there's no major change in here. Your naming convention did not change. Importantly, what changes is your MapReduce part. Now, the MapReduce is called job tracker is called what in Hadoop 2?
Node manager.
Well, you said node manager. Yeah, node manager is not the master. Node manager.
Oh, it's a resource manager. Sorry.
Perfect. Yeah. Okay. So these are the only daemons that we need to be talking about. And in here, apart from the name node, we also have something called as secondary name node. Okay. Now we called it the secondary name node. Did we talk about this? I don't think so, right? Okay. I have not introduced secondary name node as yet. Okay. We'll come to that. Okay. We'll talk about secondary name node today's session. All right. So now the agenda for today is we'll go a little deeper and try to understand. Okay, and try to understand HDFS components. Okay, HDFS components. Yes, Balaji, I mentioned secondary name node, but we did not go deeper into it. Okay, so this diagram I showed you, I'm showing here, right? I not put a secondary name node here, so we'll talk about that today also. Secondary name node is also called sometimes as a checkpoint node. Okay, so checkpointing is a major function, so we'll see what the checkpointing functionality is. Right. This presentation. Okay. So what we'll be seeing now is anatomy of a read and write, like what happens when you try to upload data into the cluster, and when we try to read the data from the cluster. Okay, so first of all, I'll explain to you the write anatomy. Okay, and then we'll go back to the read anatomy. So say this is a client machine. Okay, on the client, this is a client machine. The big data what you're seeing is a client machine or a developer machine. Just visualize. It is, I think it's not given here, but this is a developer machine from which he wants to upload the data. What the developer will do is the developer will contact the name node and says, I want to upload a file. Okay, client sends a request to the name node to add a file to HDFS. Now the name node will look at the metadata, right? The metadata is all maintained in the name node, right? I explained this last week. So the metadata is maintained here. The name node will look at the metadata. When you say metadata, what is happening? The data nodes are all giving in heartbeat messages to the name node, indicating they are alive. When they say they're alive, okay, that is when the name node knows, okay, you need to go and talk to, or you need to go and write into so and so data nodes. Now, the name node at any point of time will have the latest status of what are all the data nodes available in the cluster, right? Now, that is what it looks at. It gives the client a leads path, okay, a leads to the file path. Now, for every block, okay, step 3 is for every block, the client will request the name node to provide a new block ID and a list of destination nodes. Now, just come back and see, step back and see your 100 MB file. Your 100 MB file is made up of, okay, your 100 MB file is made up of 2 blocks, right? One is a 64 MB, which is a default block size, and then the second one is a 36 MB block. Now, the name node will look at the metadata, sees what are all the data nodes available, and then it gives the location. Okay, it gives the location of the data node to the client machine. The client will directly contact the data node and then start writing in the first block here. Okay, this for the first block. Just say we are talking about a 64 MB block. So one block is written. Now what about the 36 MB block? Even for 36 MB block also, parallelly it will try to write into a separate node. Okay, so the write is parallel. Write will be parallelly, it will be trying to write it. Okay. Now, as the first block is written to the data node 1, okay, the first data node, okay, will contact the second data node in the queue and says, get ready to accept the block. Now, once the data block is completely written here, it will go and write into second data node. Right? Now, once the block is written here, now your 2x replication is met. So now all this visualizing that we have a 3x replication. When the block is written to the second data node, we'll contact the third node in the queue and ask it to get ready to accept the block. So even then, now I have the block written to the third data node as well. So the first data node pipelines the replication to the next data node in the list. So this is called as a pipeline write. Pipeline write is like a water flow. Okay, just visualize this as a tube, okay, as a water tube, and as the water gets filled in, then only it will trickle into the second tube. As this gets filled in, then only it will go into the third tube. Okay, so that is why it's called as a pipeline write. So your it's called as a pipeline replication. Okay, replication is always pipeline or sequential. So write is parallel and your replication is sequential. Okay, so see here, when I say parallel, I have multiple blocks. My file is not made up of only one block. My file may be made up of 5 blocks, 10 blocks, or 100 blocks. In that case, it will try to write so many blocks, okay, so many blocks parallelly into so many machines. So that's why you call it as write is parallel and the replication is sequential. Sequential is one after another. Guys, clear with that? Write and replication. That is an important interview question as well as a certification question. Any doubts in there? Okay, perfect. Good. Now coming to data integrity, how does the data integrity happen, right? So how is your fault tolerance achieved? How you make sure the data is proper, whatever you're writing is correctly being written? So what happens is the client is talking to the name node. I want to write a block of data. Okay, he wants to write a block of data. Now, okay, so name node is saying use the data nodes 1, 4, and 12. Right? Saying that you use 1, 4, and 12. Now, the name node is giving the location of the data nodes to the client machine. The client will write the block, okay, plus a checksum value. I think one of you had a question, I think, how does the integrity is checked here. So this is how the checksum value will be sent. Okay, the checksum value will be sent here, and then it will be entirely be written into the first node, second node, and the third node in the pipeline. Now, once it writes to the third node in the queue, it gives an acknowledgement message back to the fourth node. The third node indicates to the second node, indicating the third replication is completely written. Now, the second node in the queue will respond back to the first node in the queue, indicating with an acknowledgement. And the first one will give an acknowledgement back, a successful acknowledgement back into the client machine. Once this is all complete, right? This is all complete. Your one stream is okay. Your write, or you can say your write stream is complete, and that will be marked as completely and successfully written into the cluster. So that is what is your write anatomy all about. Now let's step back a little bit and talk about how does a read happen. Read is here. Now you have the data already written onto the cluster, somewhere available, say one block is on data node 1 and second block is on data node 3. Now I have the entire file written here, 2 blocks written here. You are as a client, you want to read the file. So what do? You will have on the client machine, you will have HDFS packages, right? Your Hadoop, your HDFS and MapReduce packages. Now when you're trying to read the file, you are especially using your HDFS package. Now, via your HDFS, you will contact the name node, okay, gives it the file name and says, this is the file I want to read. Okay, the name node will look at the metadata and gives the locations of the data nodes where these data nodes are available. Those locations will be given to the client machine. The client will directly contact that node and start reading the data there. So even this will be trying to read parallelly. So it will try to read parallelly both the blocks simultaneously. So this is about read. So write is a little bit complicated when compared to read. And once you get the file, this is what it will be shown to you on your GUI, or if you want to redirect it to a different file or onto your standard output. That is what is shown here. So that is all about read and output. Any questions on this, guys? No questions, then let's move forward. Good, perfect. Now there is something called also rack awareness. Okay, rack awareness. Let's talk about rack awareness. What is this rack awareness is all about? We'll understand the concept first, and then we'll move forward. So let's see what is this rack awareness is. Increase the size. Okay. So if you are, I think most of you are working professionals, you know how the servers will be arranged in a data center, right? All the servers will be arranged in something called as a rack, right? The racks. Now there are multiple racks available in a cluster. Just visualize I have rack 1, rack 2, and rack 3 in my cluster. Rack 1, and I have rack 2, and I have rack 3. 3 racks, and I have my data nodes spread across. Okay, 1, 2, 3, 4 4 data nodes on rack 1, 4 on rack 2, and 4 on rack 3. I have a 12 data node cluster. Okay. My data nodes are made up of 12 in total. Now the client says I want to write a file. Say for example, the file is made up of 3 blocks. Okay, just indicate 3 colors. Block 1, block 2, and let's give it some dark color. Block 3. Okay, 3 blocks. Okay, so this is your block 1. Oops. Okay, just visualize this block 1, block 2, and block 3. Now, when the client wants to write this file into here, right? This one is eraser, highlighter, and okay, let's say. So when the client says he wants to write a file here, what will happen is the data will be needs to be distributed across all 3 nodes, right? So it will write in here, okay, block 1. Okay, block 1. Okay, so it's your block 1 and replica 1. Right, these are three blocks are made. Your file is made up of 3 blocks. I want to upload the data into the cluster. Now 1 block will go here. Now 2 blocks. Block 1. Okay, my 3x replication is met here. Similarly, my blue color, say for example, it is written here. Block 2, and I'm writing it here. Block 2, and come on. Block 2. Right, then I have my green block, which will be, maybe say a green block can be written, say for example here, block 3. Do you guys notice a pattern here? Can you spot a pattern, or there's no pattern as such? Any similarity in the way the block is written?
Yes, Kumar.
Yeah. So what is that? Okay.
Like when it's writing on the first, like take an example of block 1. In the first rack, data is stored, and then in the second rack, when the replication of the block is made, and next to in the same rack, the next one got replicated than in the block. In the same way, if you look at example of block 3, in the rack 2, one of the block got saved, and in the next rack, the second block, this replication got saved here, and next and down of it, down of the block got saved. So even for the same in the block for block 2, the rack 2 block is saved, and replication, the 2x factor is again saved in the same rack.
Yeah, perfect. So you got it, I think. So see, what's happening here is, you see here, 1 block will be written into 1 node in a rack, okay, and 2 succeeding blocks will be written onto a second rack, okay, but 2 different nodes, the two succeeding replicas will be written onto the second rack, but onto 2 different nodes. Okay, so you see, block 1 is on 1 rack. Okay, block 1's replicas 2 and 3 are onto a different rack. Okay, or on a same rack, or on a different same rack, but on different nodes. Similarly, block 2 1 replica is written here. Okay, the 2 replicas are on 2 different nodes, but on a single rack. So this is what is replication, or you call it as a rack awareness topology, or rack topology is. See, Why is this? Because what happens here is there is a top of rack switch. Okay, it is called as a top of rack switch. We just have top of rack switch. Right. And the communication, why is this algorithm written this way? The reason is because in the this is within a rack. The communication between the nodes within the rack is very fast. Okay, this is very quick because it doesn't need to come out of it, and there is no network involved in there. In the sense, there is no LAN, or it doesn't require a network bandwidth. So because these are within the rack, you will have a switch here, okay, with which they communicate. They all communicate with each other. Now the communication is within the rack is very faster. Now when the communication in between the racks, they have to go via your VLAN or your network. Okay, there is something called as top of the rack switch. Within the top of the rack switch, you need to communicate. So that will bring you, okay, that will launch you into network here. So when you start writing, or when you start writing more amount of data, okay, your more network bandwidth is occupied. Right? So to avoid that, what they have come up with is, let's keep one block in one rack, okay, and the two succeeding blocks in a different rack, but also on a different nodes. Okay, so this is a rack topology all about. So one block is always written into one server in a rack, and two succeeding blocks will be written into two different servers, but on a single rack. There is not a second rack. So this is how all three blocks are set across all the nodes in the cluster. So this is something which will not be enabled by default. Okay, what will happen is the name node will assume that all the nodes in the cluster are in a default rack, or by default in a default rack. So you as an administrator, you need to indicate where these, if you enable or if you tell where each of the server is residing, and the name node will make sure it adheres to the rack awareness topology. So as an administrator, you don't need to worry about this placement. The placement will all be taken care by the name node itself. You as an administrator only need to configure what is the rack this server is residing on. That's the only thing you need to configure, and rest all will be taken care by the name node. You'll have damn sure one certification question on this. Okay, so you'll get more. I mean, it's not a direct question, I would say. Multiple, it will be twisted in such a way that you'll get confused. So if you understand the concept here, okay, you can answer any question, I would say. Okay, so that is your rack awareness. Now let's talk about MapReduce, right? Let me show the diagram that I opened. This one we talked about. Okay. So before I move forward, any questions? Any queries? Okay. Okay. Let's talk about secondary name node also. Okay, so that will actually complete our HDFS part. The HDFS core components will be completed, and then we can move into MapReduce. So, so with Hadoop 1, right? With Hadoop 1, what is happening is you have a name node, and you have something called as a secondary name node also. You have a name node here and the secondary name node. So, what is the responsibility of the secondary name node? Secondary name node is not a hot standby. Okay, it connects to name node regularly, that is every 1 hour, and picks up the metadata, okay, and it keeps for housekeeping purpose backup of name node metadata, and saved metadata can build a failed name node. So what is happening here is, okay, for your HDFS master, we said the name node is the brain of the cluster, right? If you go and see this diagram here, the name node is the brain. The data nodes all send in heartbeat messages to the name node. Now what if this master is dead? If this master is dead, the data nodes do not know where they go and write, or where they give the heartbeat messages. The client machine, who is the first of all contacting the name node to write or read the data, does not know where he can go and write, right? Because the metadata information itself is not available. All your brain is taken out. So if the cluster's brain is dead, you will not be able to make anything, your cluster is of no use for you. Your entire cluster will be down. Okay. One more important thing I want to stress here is coming back to the write anatomy, right? Very, very important thing I want to mention. See, when the write happens, the read happens, right? The data will never go to the name node. The data will always be flown to the data node. Okay, the name node will come into picture only initially, okay, only for the first time, and the data will never flow here. Okay, I hope you have noticed that part. The client will directly write into the data nodes, data node 1, okay, and then it will be replicated here. So the data will never go to the name node. It's only the metadata information is what is stored here, and only for that purpose the client will contact here. And the client will directly establish contact with the data nodes. Whichever data nodes are available in the queue, it will contact that particular data node. Now, coming back to the secondary name node part, secondary name node is not a hot standby. So when you bring it down, right? So it is a hot standby because it's not a hot standby because it's not failover automatically. Then it connects to name node regularly. Housekeeping, saved metadata can build a failed name node. I think we talked about this, guys, right? We talked about this. Now when I say saved metadata can build a failed name node, every 1 hour it picks up the metadata. Now the metadata is in terms of fs image and edits log file. The metadata is stored in fs2 locations. One is an fs image. Okay, it's stored as 2 files. One is an fs image and the second file is an edits file. Now edits is a file which does all the incremental additions to the cluster. I think I don't have a diagram of that. Okay, let me put that diagram also. Did we see checkpointing function, guys? No. Yes. Checkpointing. Oh yes, I think we did talk about checkpointing. No, here it goes. Yeah. Okay. Sorry, guys, I keep asking that. I do multiple batches, get confused myself. Sorry about that. Okay, let's talk about something called as a checkpointing. Yes. So I have a name. So I have a name node here, and my secondary name node. Node. Secondary name node. Now within the name node, the metadata will be written into 2 locations, right? The metadata will be written as 2 files. One is an fs image. Fs image. The next one is edits log file. Edits log file. Now every 1 hour, the secondary name node will contact the name node and says, give me the metadata. Okay, because there's no backup here, right? So it will contact the name node and give me the metadata. What will happen? This metadata will be given in the secondary name node here. So for example, let's just keep periods here. and your FS image. Okay. Now what does the second name node do? It keeps a copy of this FS image and edits log file. Now next, once it gets these two, it combines these together. Okay, combines these two together to make a bigger file. And what is the bigger file is? That bigger file is called as a fs image.ckpt checkpoint. Okay, it makes a bigger file of this and then copies this file back, copies it here and renames it as fs image. Be a bigger file because we are combining fs image and edits file, right? So it's a bigger file. Okay, while this edits, right, when this is happening, the edits will be renamed into something called as .new, edits.new. I'll just explain this flow, guys. And this edits.new will be rolled back into edits file. Okay. Now, what is this fs image and edits file? See, when you format the cluster, you will have an fs image file created where all the metadata will go inside. There is a one file, it's a static file. Now, when the client says he wants to write some data into the cluster, right? He wants to write some data into the cluster. What will happen is all the incremental additions, okay, all the incremental additions will need to go into one metadata location, and that metadata location is nothing but your edits file. Okay, the client or whatever the client is writing, all that will be written into edits file. So edits file is dynamically updating, all incremental data will be in here. Now this keeps on increasing, this keeps on growing in size. Okay, at some point of time this has to be merged with your fs image. Fs image is a static file. Now we said secondary name node will be is not a hot standby, will be contacting your name node and picks up the metadata every 1 hour. It takes the metadata. What is the metadata? Your fs image and edits file. When it copies fs image and edits file, because edits is containing all the incremental additions, what it will do is it will roll edits file into edits.new file, so that when a client tries to write at that point of time, it will go, the metadata will go into this location. Okay, now I have only edits.new file here, there is no fs image. Fs image and edits file are here. Okay, now this will be combined together, made it as a checkpoint image. Your fs image and edits will be combined together, and this checkpoint is launched back or copied back into the name node. So now I have a bigger fs image file containing all the incremental additions, all the metadata within your edits file. So your fs image and edits file data is all combined together to have a bigger fs image. Now while this fs image is copied back here, the edits.new will be rolled back into edits file. So this is what is all the checkpointing is all about. This process is called as a checkpointing process, and the secondary name node is also called as a checkpoint node. Okay, and this keeps on happening every 1 hour, and I think last week, as I asked last week, because we always have a risk of losing at least 1 hour's metadata, because say 6 a.m. it has copied the metadata, and about 6:55 a.m. or 6:44 this name node is down. That means all the incremental additions that are written here are lost. Clear with this, guys? Checkpointing part. Okay, perfect. So we talked about checkpoint. checkpoint function also. Okay, now let's go straight into Hadoop 2. Hadoop 2. Let's start drawing. This will take a lot of time. Let me see if I have a diagram in here. Okay, let's show you this part. Now, Hadoop 1 is what we have been talking about. So if you look at this, right, you store the data and then you process the data. So in your entire Hadoop is only these two things, right? You're storing the data and then you're processing whatever data is available on the cluster. So this is how it is. Your Hadoop 1 is. Now introduce Hadoop 2. With Hadoop 2, what you're doing, you're storing the data and then you're processing the data, but here you have replacing your MapReduce with something called as a resource management, right? Your yarn. Yarn is yet another resource negotiator. You're replacing this part here. So what is this yarn and what is the functionality of yarn? Anyway, we'll see when we go deeper into Hadoop 2 functionalities or yarn functionality. But primarily, if you look at here, HDFS, okay, HDFS is same across your Hadoop version 1 and Hadoop version 2. It is same across these two versions. Only thing is, in between, earlier you can run only MapReduce programs, but now apart from MapReduce programs, you can run some other programs also. That is because your resource management, right? Your resource management has been segregated and given it to somebody called as yarn. So we'll come to that when we talk about yarn part. Importantly, what I want to talk about right now is something called as a HDFS features. Introduce to you the HDFS feature. Unfortunately, I don't have a diagram here. I need to draw this. Just bear with me, guys. The mouse is somehow not working good. I don't know what happened. Okay, this looks better. So Hadoop 1, if I say it's my Hadoop 1 architecture, this is my name node. I'll quickly draw this, guys. This is my secondary name node, and I have, say for example, 3 data nodes, which I'm calling as data node 1. Then I have DN2, and then finally I have node 3. So all 3 will be sending in the heartbeat messages here. Okay, your metadata is here, and secondary name node contacts the name node and picks up the metadata. Now this is your Hadoop 1, guys. Okay, Hadoop 1. Let me save this. Hadoop 1 HDFS. Now quickly try to draw Hadoop 2 also. New. With Hadoop 2, what we are saying here is, this is your name node. Okay, I also have it. Similarly, I have 3 data nodes. Name node, and this I'm calling as secondary name node. Okay. So now the secondary name node is replaced with something called as standby name node. Okay, I have a name node and I have a standby node, and my metadata, whatever metadata I'm writing here, will be in a centralized location, in a shared location. FS, or you can say my edits file, my shared edits file. FS image will be here and here, but your shared edits will be written into a file, not onto the local disk, but onto the file. Look at the arrow directions, what I'm doing here. Okay, so let me finish up the diagram here. I'll explain to you part by part. This is my data node 1, data node 2, data node 3. Heartbeat message from name node, from data node 1 to name node, 2 to the name node, from data node 3 to the name node. data node 1 to standby node, data node 2 to standby node, and data node 3 to standby node. Okay, now primarily your secondary name node has been replaced with something called as a standby node. That means standby node is not contacting your name node for metadata, right? And it is still available, and what it is doing is the edits log file is not being written in this location in the name node itself. It is being written into a shared location, right? So there's no requirement, or there's no necessity for the standby node to contact the name node every 1 hour. The moment it writes here, okay, the moment it writes here, this is available to both the name node and the standby node. This is a filer, this is an NFS filer or anything. The moment the name node writes the edits log here, that will be picked up and applied to the standby node here. Because your metadata is both what? Your metadata is your FX image and edits, right? So the moment it writes here, it will be picked up here. Now, one of the important difference, if you see the data node communication, right? If you are spotting the difference, if you seen the difference here, with Hadoop 1, this is what I said, right? Your Hadoop 1 secondary name node contacts name node and picks up the metadata. But if you see the connection here, the communication here, what is the communication difference here? Oops. Yeah. The communication difference here is the data nodes contact, that's right, Balaji. The data nodes will be contacting standby node also. Now just visualize your name node is down for some reason. Okay, your name node is down for some reason. Now what will happen? There will not be any impact in this place because your edits log has been pulled out of the name node. It's being written outside of the name node onto a shared location. The standby node has access to the latest edits log. Maybe a few seconds here and there, maybe you might be losing the data, but then it has got the edits information here. Now earlier with Hadoop 1, what we had to do? Okay, with Hadoop 1, what we had to do is, if the name node goes down, we need to rename the secondary name node as the name node. Okay, bring it up as a name node, change the IP address, and start the name node process or the name node daemon, because the data nodes know only the name node information. Data nodes do not have any information about secondary name node, because and they only know the name node, so they will keep on sending in heartbeat messages to the name node itself, right? That is with Hadoop 1. With Hadoop 2, you have standby node where the data nodes know the location of name node as well as the standby node. They also have the intelligence to know. Okay, it's all the configuration, guys. When I say the intelligence, it's all the configuration. So in the configurations, you mention what is the name node, what is a standby node, and if there is a automatic failover in there. Now the data nodes will look at the property and says, yes, there is a failover. I mean, there is a standby name node available. So if I am unable to contact my name node, I need to contact my standby node. Okay, that is all about your we talk it as high availability.